Sponges don't give up their secrets easily. Their apparent simplicity is both provocative and perplexing. At a distance, they seem solid. But a closer look reveals a labyrinth of tiny holes, tunnels, and chambers. Scientists have described more than 9,000 different species of sponge. They thrive in salt and freshwater environments around the world, turning up in the most bizarre and unexpected places, from the frigid waters of the poles to the warm seas of the tropics.
We need sponges to study in the lab, and so we have to collect specimens. But we need to just cut a small section to be examined, and because it doesn't have a nervous system, we are not really hurting it. In time, the cut area will grow again as if nothing had happened to it.
All animals rely on cell-to-cell communication. But Diaz and others have been able to show that sponge cells have a unique way of working together.
Cell-to-cell communication is very important for all organisms. But in sponges, it's uniquely important because in sponges, cells carry out all the functions that other organisms are taken care of by specific organs like the heart or the nervous system or the skeletal system or the blood. So sponge cells have many responsibilities to perform.
While the sponge appears strikingly different from other animals, it does share some basic hallmarks of animal life. Its cells are held together, in part, by a protein called collagen, which is possessed by all animals on Earth.
Collagen, which is the most abundant protein in the animal world, forms the supportive system for the sponge body. Most people, when they think of a sponge, they think on their bath sponge. And when you have a bath sponge in your hand, what you're holding is a soft skeleton that is made of collagen.
But unlike the bath variety, many sponges aren't soft at all. In addition to the soft collagen of the bath sponge, many have millions of brittle crystalline spicules embedded in their bodies. Spicules are microscopic structures that help give a sponge its rigidity and form.
Spicules are an incredible tool for us today to identify most of the sponges that are living in the oceans.
For most sponges, the glassy spicules act as a kind of fingerprint. Magnified, their dazzling array of shapes and sizes are as beautiful as they are unearthly. If the sponge is indeed an animal, it must eat to survive. How does it feed itself when it has no obvious mouth?
A sponge is actually a fantastic pump, which requires an incredible coordination of cells to function. It's a living filtering machine. It lives by sucking in water and filtering out food particles.
These seemingly motionless creatures are working extremely hard in order to feed.
Imagine that to get an ounce of food, a sponge has to pump over a ton of water through itself. Now, can you imagine doing that yourself? drinking a ton of water to get an ounce of food to your body.
To make the invisible visible, Diaz injects a harmless colored dye into the water near the body of a sponge.
One of the ways we can test for the rate of water flow that moves through the sponge body is to inject a colored dye and measure the speed at which it is pumped through the sponge. When I start seeing the colored dye coming out of the sponge in less than 2 seconds from when it was applied, I could not believe my eyes. This steady and strong continuous flow of water continuously coming out of the sponge was an incredible realization of the dynamic existence of this organism. It's an incredible sight to witness.
These ghostly exhalations are proof that the sponge is actively pumping. With no mouth, it sucks water directly through its sponge-like body walls, which are shot through with millions of narrow canals and tiny chambers. How does it do it? The best way to find out is to enter one of the many portals into the sponge's secret inner world. Drifting along with countless single-celled organisms, we feel the tug of a current. In the wonderland within, this sponge's cells all work for the common good, but they do it in wildly different ways. As the current draws us on, we pass sponge cells that are making new spicules. The walls themselves are treacherous. They can simply engulf their unfortunate prey. As we are drawn through ever narrower passages, the current slows until we burst into one of the sponge's millions of tiny beating hearts. These are choanocytes, cells whose whip-like flagellae powers the pump. The flow quickens again as it whisks us away through the labyrinth of canals that lead out into the sponge's central cavity. What once seemed barely alive is actually a living animal, more complex than we could have imagined. The sponge's pumping does more than satisfy its hunger for food. In fact, its sex life depends on pumping as well. Set adrift, some sperm will be lucky enough to enter another sponge of the same species. If the sperm are truly fortunate, they will fertilize the eggs within. Our intimate tour of the sponge reveals a creature full of surprises. From feeding to reproduction, it engages in elaborate behavior. More than a mere aggregation of cells, the sponge is in fact a living, thriving animal.